Welcome to the 2025 Industry Project Awards Winner Ceremony. This is the Steel Framing Industry Association's award presentation. I am SFIA Executive Director Don Allen, and today we'll be looking at some beautiful, unique, and innovative designs and construction methods. I've had the opportunity to review all the entries, and frankly, there are many more projects than what you're going to see today that are award-worthy. And now, for this year, we also have an Innovative Product Award. So on with the show. But first, a little bit about the Steel Framing Industry Association. SFIA is dedicated to expanding the market for cold-formed steel and construction through programs and initiatives that promote the use of cold-formed steel framing as a sustainable and cost-effective solution, advocate the development and acceptance of favorable code provisions, educate members with reliable data and other critical information that's essential to effective business planning, and create a positive environment for innovation. SFIA represents the entire supply chain of cold-formed steel framing, including steel mills, manufacturers, suppliers, distributors, contractors, design professionals, and anyone engaged in the use of CFS framing. And this type of framing is used in more than 35% of all non-residential construction across the United States and in North America. We have many programs at SFIA. Our newest is the Code and Standards Development Process for CFS Framing Standards. In 2024, the SFIA became an accredited ANSI Standards Development Organization, and as such, SFIA will be responsible for the development of several of the framing and test standards that deal with framing. You'll hear more about this shortly. Our signature program for developing and maintaining trust in properly manufactured framing products, stud and track, and even proprietary products is our Code Compliance Certification Program, or C3 program. This provides third-party assurance that studs being used by our contractor members meet all building code requirements. The certification program itself covers more than 3/4 of all stud and track manufactured in the United States. And right now we are in process of updating the program. Last week it was approved by our board of directors for an update, and we'll be taking this out to our membership shortly. We've already talked about it a little bit in a couple of our town halls. But we at SFI have market data and business planning information available, and we provide marketing, educational, and technical resources. Our promotional platform for cold-formed steel framing, BuildSteel.org, is where you can go for more information and ideas, and our Steel Framing Learning Portal, where you can register for live webinars and complete on-demand courses. So without further delay, let's get into the SFIA Industry Project Awards. This is only our third year, but every year we get more submissions and more interest. This year we received 28 project and 2 product submissions, which is the most qualifying entries received so far. Note that to enter, you must be an SFIA member. Additional recognition and trophies will be handed out at the 2026 SFIA annual meeting in conjunction with Build 26 in New Orleans. More on that later. Our judging panel consisted of these 3 fine gentlemen: Tim Blattner in the Chicago area, the principal of Fitzgerald Associates, and Tim has served as the former director of the Construction Specifications Institute Chicago chapter. Paul Dahlia is a professional engineer and heads up 5400 Engineering, LLC, in the Orlando, Florida area. And Roger LeBoux is a longtime friend and colleague and former professor at University of Missouri-Rolla, and currently resides in the St. Louis area. So these 3 gentlemen have taken their time to look through and sort through some really good entries, and we're going to see what they selected for us in these 8 winning project categories. So without further ado, we're going to go to the first category, low-rise project. And the honorable mention in the low-rise project goes to UCSC Student Housing in Santa Cruz, California, submitted by Wayne Capers of Adco Drywall and Metal Framing. So using a combination of cold formed steel and structural framing, ADCO was challenged to frame 30 individual residential buildings and 2 community centers in just 3 months. They used a large crew of 130 workers, 4 cranes, and this allowed the team to meet the schedule while experiencing the many rainy days of Santa Cruz weather. This project was pre-panelized, so all walls were framed off-site and then trucked to the job site and craned into place. The judges commented that this was a fast-paced project with a large workforce, and sometimes the coordination of this type of project is difficult, but the folks were able to pull this off quite well. And now to the winner in the low-rise category. This goes to R.A. Smith on Wind Creek, Chicago Southland Casino in East Hazel Crest, Illinois. And it was submitted by Brian Scupian, who is one of our volunteers helping out with SFIA programs projects in our recently released and just posted this afternoon on our website, updated product technical catalog. So in this project, the Wind Creek Chicago Southland Casino, wherever feasible, the design incorporated continuous in-plane members such as tracks, strongbacks, kickers spaced at 4 feet on center to minimize the number of labor-intensive connections. This strategy enhanced efficiency by allowing a higher percentage of each connection's capacity to be utilized while using standard cold formed steel sizes and shapes. In-plane gypsum sheathing was also utilized and designed to create vertical diaphragms to support hanging framing and span between the designated connection locations that were coordinated with in-place mechanical, electrical, and plumbing systems. Additionally, the project required creative solutions in several areas to ensure the standard readily available CFS sizes could be used effectively. For example, several openings were nearly 30 feet wide, supporting stone panels above, so lots of heavy cladding on the outside. These openings were originally designed with hollow structural shapes, also known as tube steel members, but were value engineered with cold formed steel framing members to reduce cost and size. To size a header to span that distance and support the full dead load, a traditional box header was combined with additional studs framed similarly to an L header. This approach provided the necessary structural capacity for framing conditions with readily available materials without having to make this custom. So again, the winner in this category was the Wind Creek Chicago Southland. Architectural design for this project pushed the limits of what's possible to be framed with cold formed steel, requiring creative engineering solutions. The interior finishes needed attention-grabbing features throughout. With that in mind, R.A. Smith designed CFS framing to support more than 30-foot tall floor-to-floor heights, large openings in soffits, radiused and sloping walls in soffits, and multi-tiered column covers. While each of these framing conditions presents challenges of their own, incorporating all within a single project significantly increased the complexity. The judges noted that it really shows the versatility of cold formed steel framing with all these curves, these long built up members, the complex headers that were used to efficiently replace the structural steel elements. Moving up to the mid-rise project category, the honorable mention also came from R.A. Smith with the Trade Hotel in Milwaukee, Wisconsin, submitted by Susan Debrinsky. This project demonstrated a highly efficient use of cold formed steel by tailoring the framing design to accommodate varying floor-to-floor heights, including extra tall levels designed for professional athletes. Each level was individually engineered to optimize material use and structural performance. Where possible, structural steel was avoided in favor of cold formed steel, and design efficiencies were communicated through approver notes to the design team. At lower levels with greater spans, 8-inch and 12-inch studs were selected in many cases in order to reduce the required stud thickness, ensuring the lightest possible wall weight while meeting strength demands. This is something I hate that happens in design, but late in the construction process, it was discovered that steel lintels had not been provided to support brickwork above first level openings. A collaborative solution was developed with the engineer of record to utilize the already installed CFS studs to support the brick, eliminating the need for additional structural steel members. This not only resolved the issue efficiently, but also maintained the project schedule and budget. The judges commented that they liked the way the complex windows were handled on the bottom floors. And as you can see in this image, those are quite complex windows. And now for the winner in the mid-rise category is from Negwar Materials, One River Run in Kindred Resort in Dillon, Colorado, submitted by Carl Klosterman of Engineered Steel Products. This project made highly efficient use of cold form steel products by utilizing 12-inch joists to achieve the vaulted ceiling designs while maintaining a lightweight structure. The cold form trusses were engineered specifically to transfer diaphragm loads effectively and minimize the overall dead load on the building. By maximizing the inherent strength-weight ratio of cold form steel, the design achieved long open spans without the need for heavier structural systems. This approach also provided a value engineering solution by reducing material quantities and simplifying installation, ultimately lowering both structural cost and construction time while preserving the desired architectural aesthetic. The project presented several complex installation challenges requiring special techniques. The open floor plan limited the number of interior walls available for diaphragm load transfer, so the team had to install drag trusses, blocking, and complex connections to beams and elevator shafts to properly distribute loads. The vaulted ceilings further constrained available space for mechanical systems, which required detailed BIM coordination to identify and resolve potential conflicts before and during installation. Construction took place at the base of a mountain within a ski resort, introducing difficult site logistics due to limited staging space, steep terrain, and a 5-story building height. Additionally, many of the truss loads spanned over 100 feet, requiring careful sequencing and specialized rigging to maneuver and install these large components safely within the tight site constraints, in close collaboration between the trades to maintain safety and meet the project schedule. This project involved a high degree of manufacturing complexity. The cold form steel trusses were designed to support structural tube steel beams and ridge beams needed for the vaulted ceiling architecture. Due to the significant diaphragm loads, 7 of the trusses had to be fabricated as structural tube steel trusses to meet performance requirements. Panelization was a key strategy used on the project, allowing a large selection of the framing to be pre-assembled off-site for improved quality control and faster installation in the field. This approach also helped mitigate the challenges of the limited staging space and difficult terrain at the mountain resort location. Special coordination between the design, fabrication, and installation teams was essential to ensure all custom components were manufactured accurately and delivered on schedule. The judges commented that the use of building information modeling, or BIM, was very helpful in this complex job, and the fact that they used value engineering through the difficult site logistics really contributed to them choosing this project as our winner in the mid-rise category. So on to the high-rise project category. The honorable mention in this category is 24th and Rio Grande Housing in Austin, Texas, submitted by Jenny Hull and other SFIA members involved, in addition to Clark Dietrich, or L&W Supply, and the Steel Network. This project made use of cold form steel products by utilizing a prefabricated panelized system along with a drift track attachment method. The project team was able to stack the panels efficiently, creating a robust and seamless outer skin for the building. The system was transitioned to a prefabricated panelized approach to significantly reduce both time and cost. This shift also minimized on-site labor and reduced material waste, contributing to a more efficient and cost-effective project overall. With this being a panelized system, it required careful planning for the transportation of the panels from the panel shop to the job site to prevent any damage during transit. A combination of a crane and a monorail system was strategically employed to lift the panels into position, ensuring precision and safety. Special attention was given to weather conditions, particularly at high altitudes, to mitigate the risk of accidents or delays caused by wind, rain, or other environmental factors. And when you lift one of these panels on a crane, it's like a big sail, and you have to be very careful of the wind and tag lines and get it to exactly the right place. The judges commented for this high-rise honorable mention project they commented on the detailing and pre-paneling planning required to make the panelization and transportation run smoothly. And the winner in our high-rise project category is from T.J. McCartney and Alston Lab Works in Boston, Massachusetts, submitted by Jesse Valancourt. This project efficiently used CFS products to eliminate the need for heavy and more costly tube steel, hollow structures shapes for the curtain wall. So all of this curtain wall support was able to be done with the cold form steel framing as the exterior framing. There were numerous flyby box jambs spanning multiple stories. They were prefabricated on site and then installed with a tower crane, as some of these elements weighed over 600 pounds each. The team utilized a radius track manufacturer to make custom radius track and box beam sections at the curved corners of the building. Another stud manufacturer made custom angle clips for the slopes of the building. Outside of these two items, everything else was standard cold form metal framing of various depths and thicknesses to complete the envelope of the project. The project underwent extensive building information modeling coordination in the pre-construction phase to make sure design intent was fulfilled. Walls were laid out to hold up the dimensions of the outside face of sheathing and bring any cold form metal framing buildup into the interior of the building. Light XY laser layout was used to shoot all horizontal and vertical points from the coordinated model. The judges commented about the BIM and laser layout used. Also enjoyed the fact that in the submission there were lots of good photos of both the construction and the completed building. And of course, the complexity of the geometry for the exterior walls really led to this achieving the first place award in this product category. So on to the next category, efficient use of cold form steel framing. And the winner in this category is Industrialized Construction Solutions, West Point 2 Apartments in Tucson, Arizona, submitted by Matthew Comer. So this project team leveraged cold form steel to enable a full 7-story superstructure without the use of a concrete podium, overcoming a critical cost barrier. Strategic early coordination between the architect of record and the structural engineer of record, who also served as the prefabricated CFS specialty engineer, allowed for vertically aligned bearing walls from the upper apartment levels through the first floor, amenities programming to the foundations, eliminating the need for concrete or red iron transfer beams. In addition, through careful study and design coordination, built-up cold form steel stud packs were used in lieu of tube steel for shear wall hold downs and balcony support elements, delivering a savings of over $1 million while maintaining performance integrity. All in all, the only red iron employed in the entire project were some wide flange moment frames at the first floor to provide a vertical and lateral load path at the expansive storefront openings. So, located on a constrained downtown infill site with limited staging, the project required a framing system conducive to just-in-time delivery and expedited assembly. A prefabricated panelized cold form steel solution was selected to meet these needs, enabling clean sequencing and minimizing site congestion. The use of an all CFS superstructure, including floor C-joists, eliminated the need to coordinate separate concrete trades for the floor pours, simplifying logistics and reducing risk of inter-trade delays. By consolidating floors and walls under a single subcontractor scope, the framing phase proceeded without trade handoffs, resulting in tighter scheduling control, improved crew efficiency, and overall schedule reduction of a two to 3 days per floor. The reduced weight of the cold form steel floor system also reduced structural weight, contributing to significant foundation cost savings. Despite the logistical constraints inherent in an urban infill site, the 7-story structure was erected in just 75 days, accelerating occupancy and project revenue. Prefabrication leveraged CNC, a roll form panelization approach allowed for on-demand fabrication of 800S200 joists, mitigating supply chain risk. The structural engineer of record also served as the prefabricated CFS specialty engineer and leveraged their custom-built software solutions to directly translate data from the Revit structural model into production-ready wall panel shop drawings and roll former production files, eliminating the inherent coordination risk and schedule delays associated with the traditional PDF shop drawing handoff process between multiple design, engineering, and fabrication entities. Panelized CFS construction yield high dimensional accuracy and a finished quality, ensuring consistent alignment across floors and facades. A sheet steel shear wall system was selected as the primary lateral force resisting system to ease the drywall installation process and minimize the shimming often associated with local buildups encountered with strap-based systems. The integration of prefabrication and field coordination delivered the design intent with minimal rework or deviation, while enabling early occupancy and reduced general conditions costs. Quality assurance measures upheld stringent tolerance standards, enhancing both the visual outcome and long-term building performance. So the judges' comments, the project used lots of steel in cold form, including shear wall sheathing, and they also liked the way the story, the narrative described the way cold form steel allowed this entire building to pencil out. So that was our winner in our efficient use of cold form steel category. Now to the category conversion from another material. And the winner is Simcoe Mullen Transportation Design Center in Pasadena, California. This was submitted by Zachary Peterson. While structural elements were always intended to be steel, the cold form elements played a crucial role in replacing traditional framing methods, examples were wood or structural steel, in interior assemblies. The substitution reduced material weight and made possible the installation of floating architectural features without additional structural supports. The use of CFS also supported LEED goals by reducing construction waste, improving speed of assembly, and allowing for better integration of mechanical, electrical, and plumbing systems, leading to overall schedule savings and a reduction in potential construction risk. Cast-in-place concrete upper-level decks supporting light metal framing, structural steel framing was chosen for its load-bearing capacities and adaptability. This made efficient use of cold form steel products through the integration of lightweight, high-strength framing that supported the building within a building concept. Cold form steel was instrumental in maximizing the strength of weight. Maximizing the strength of weight ratio, reducing the structural load on the original slab while allowing for architectural flexibility. A major value engineering success involved converting heavier structural framing into CFS assemblies for non-load bearing partitions, soffits, and ceiling structures, which reduced material costs and simplified installation without sacrificing durability or performance. This helped maintain seismic separation between the new structure and the historic shell. Originally home to a supersonic wind tunnel operated by Caltech, the MTDC draws inspiration from its aeronautical history. The design features a building within building concept with 63 piles supporting a series of grade beams and columns. This innovative approach allows for a seismic separation from the historic structure while creating a unique aesthetic of lightness and hovering forms. Mullen Transportation Design Center prioritized in-place conventional construction techniques, including cast-in-place concrete decks. Many components were custom fabricated to meet the architectural requirements of floating forms, curved ramp walls, and high-finished exhibition areas. In several locations, cold-formed steel was used to create a curved framing and multi-planar intersections that traditional framing could not accommodate. While some materials were standard, the project heavily relied on modified profiles and pre-assembled components to meet tight tolerances and accelerate installation. Panelization was used strategically where space allowed, and sourcing had to be carefully managed due to specialty thicknesses and shape requirements. The Mullen Transportation Design Center stands as a testament to the evolution of design processes related to transportation and modern aviation. By blending history with contemporary design, this facility not only enhances the educational landscape, but also serves as a focal point for innovation and collaboration. The final product achieved exceptional alignment and finish, critical in a facility designed for display, education, and architectural exposure. The CFS framing supported seamless transitions between wall and ceiling planes, allowing for high-end finishes and integrated systems to be flawlessly executed. The framing fulfilled the design intent to evoke a sense of hovering structures and lightness within the space, especially in areas where visibility and transparency were key. Quality control was rigorous, and the final walkthrough revealed minimal punch list items, a testament to the framing team's precision and attention to detail. The judges commented that this had a beautiful interior, and of course that they provided excellent pictures of both the under construction project, the completed project, and the skeleton of the existing building, as well as the new construction within the building. So this was our winner, the Mullins Transportation Design Center, as the conversion from another material. Our next category is architectural design detail, and the winner, the honorable mention goes to Maxan Interior Systems Westerly 2 South Tower Canopy in Etobicoke, Ontario, Canada, submitted by Doug Villeneuve. Other SFIA members involved includes DASS Metal and MTE Consultants Incorporated. This innovative project employed standard metal studs and angles to create a dynamic, free-flowing architectural shape that aligns seamlessly with the architect's original vision. MTE undertook meticulous calculations to ensure the support structure effectively transferred loads back to the foundational concrete and the underlying steel stud rib framework. By utilizing a stud beam system made up of interconnected studs and tracks, a robust structural backbone was established, allowing the intricate ribs to be securely supported. This design not only fulfilled the aesthetic aspirations, but also adhered to the engineering principles, ensuring stability and durability throughout the structure. The canopy's installation was reevaluated after the steel backbone and ribs were in place. The acceptable tolerance for the metal panels is 10 millimeters, and the actual physical build was within 2 to 6 millimeters. Given that this structure does not follow a defined grid line for reference, this level of accuracy reflects a high standard in both the installation procedure and the workmanship involved. Cold-formed steel was efficiently used throughout the interior of this project, including a rooftop portion around the penthouse, as you can see in this photograph here. With no straight or 90-degree angles inside the entire building, all walls were value engineered to determine the most cost-effective and strongest method of construction. Within this aspen tree-inspired, LEED Gold certified, carbon positive, 13-story high-rise hotel, everything is round. Many unique methods were used to complete the architect's vision. From radius walls, the custom windows throughout, and stringent sound mitigation requirements, every aspect of construction proved challenging and unique. Due to the subcontractor's interior scope, no special equipment was needed. With the round walls within the interior, this project was stick frame due to the custom circumstances throughout. It was determined early on that panelization would not prove to be a logical choice for constructing the interior. The punch list issues minimal. Both the interior subcontractor and the general contractor were very pleased with achieving the design intent of this challenging and beautiful project. As you can see, the unique shapes of these windows were able to be accommodated by cut and bent cold-formed steel specialty framing around both the top and bottom curves. The judge's comment on the Populous Hotel was that they appreciated the many processes and finish shots of the project that was provided, so both during construction and the finish. And now for the project category, sustainable project. The winner in the sustainable project category is Industrialized Construction Solutions, Inc., Sunset Indicator Industrial Park Phase 1 in Las Vegas, Nevada, submitted by Matthew Comer. This project was conceived as an energy-efficient alternative to conventional tilt-up concrete construction in an industrial warehouse building complex. We have seen lots of tilt-up construction with warehouses and data centers, and it's good to see cold-formed steel substituting for tilt-up construction in projects such as this. Instead of using traditional methods, load-bearing prefabricated CFS panel construction was used to build these 6 warehouse buildings that are as tall as 35 feet. This shift allowed for a continuous insulated envelope using exterior rigid and cavity batt insulation, delivering superior energy efficiency and addressing the impact of evolving code requirements in Las Vegas. The wall system was designated to integrate seamlessly with long-span roof trusses and interior mezzanines using 8-inch cold-formed steel framing for durability and alignment. The resulting solution provides both short-term construction benefits and long-term operational advantages, avoiding future retrofits needed and ensuring compliance with stringent energy ordinances. The framing system was executed using prefabricated panelized cold-formed steel construction across all 6 buildings, incorporating both load-bearing wall panels and floor cassettes. This approach enabled efficient sequencing, allowing framing operations to proceed swiftly with a limited crew. Due to the height of the wall panels reaching up to 35 feet, the team elected to erect CFS panels without sheathing to reduce weight and ensure safe handling during placement. Sheathing was subsequently applied in the field using conventional methods. The consistent installation rhythm across the site supported predictable scheduling, improved labor productivity, and helped maintain a high level of quality and control throughout the framing process. The scale and configuration of the warehouse complex presented unique framing demands. with buildings reaching 35 feet in height and incorporating both long-span CFS roof trusses and interior mezzanine levels supported by the exterior bearing walls. The structural design required heavy-duty assemblies. Load-bearing wall panels used 8-inch CFS studs, while the mezzanines relied on long spans 1200-200-68 joists at 12 inches on center spacing to support office loads. Under typical conditions, sourcing these large profiles at scale would necessitate special ordering and long lead times. Instead, the project capitalized on CNC roll-form panelization, enabling the panel fabricator to produce the heavy required profiles on demand. This approach ensured full design flexibility without schedule disruption and delivered consistent tolerances critical for long-span multi-building installation. The CFS system produced a clean, highly insulated envelope that met both aesthetic goals and high-performance operational targets. Continuous insulation, air barrier continuity, and tight panel tolerances contributed to an energy-efficient shell that will continue to provide investment returns to the owner over the life of the buildings through minimal energy costs. All 6 buildings maintained consistent alignment, detailing, and visual uniformity, demonstrating repeatable successes at scale across the development. The judges commented that converting from concrete was done for energy savings, but also showed the sustainable performance of CFS framing. On industrialized construction solutions at Sunset and Decatur Industrial Park Phase 1. And finally, the judge's choice category. This is the last of the building category. We still have the product category, but I got really excited by the judge's choice. And the judge's choice award goes to KHSS Contractors Dark Universe at Universal Epic Universe in Orlando, Florida. This was submitted by Janet Puglisi, and other SFIA members involved included Clark Dietrich, Simpson Strong-Tie, and Foundation Building Materials as the supplier. Just take a look at this structure and you'll see the complexity of the shapes and the configurations and the finishes and the curves. There's hardly a straight line in it. This unique theme park attraction encompasses 6 connected structures, 4 of which are 1 to 2 stories plus 2 towers reaching 90 feet tall. Collectively, they create an immersive, movie-like environment that relies on the intricacy and the complexity of framing to tell its story. Overlapping roof lines, sinking walls and chimneys, and unique configurations of angles and slopes all play a role, and purposefully imperfections are major parts of the design intent. Because of the uniqueness of the project and the many types of building materials required, the design allowed for flexibility in the use of products by multiple manufacturers. The project made efficient use of manufactured CFS connectors, bridging blocking, headers, jambs, among other items to support the intricate theme facades based on the interior and multiple exterior wind exposure categories. Mind you, this is in Central Florida, so hurricane wind loads on these structures. The project efficiently utilized CFS in many long span ceiling conditions, longer than 20 feet, and tall walls exceeding 40 feet in height. The design was coordinated with all trades to minimize the amount of structural steel required on the project. An example of this was CFS ceiling framing, which served both as support for overhead MEP systems as well as the themed plaster ceilings visible to the public. These joisted ceilings were supported by CFS walls and eliminated the need for secondary steel, which saved the project schedule and money. And here you can see some of the overhead framing in those ceiling areas with the concealed MEP above. To reduce the thickness and weight of themed plaster required by the project, many of the architectural shapes throughout all structures were formed more precisely with cold formed steel in lieu of plaster and cast products. This solution was especially helpful in decreasing the weight of the many facades. The project's theming craftsmen relied heavily on framing craftsmanship to form components such as archways and organic silhouettes and angles. Through value engineering, this resulted in the best use and efficiency of materials. While it required more intricate framing and exact modeling, the process was completed without sacrificing aesthetics and while maintaining the design intent. The project was far from conventional vertical framing. Its complexity was immense, not only because of the project's size and intricacy, but because none of the 550 tons of framing was repetitive. Wall spans range from 2 to 50 feet, each entirely unique. This project had no comparable. Nothing was off the shelf, since nothing about it had been created elsewhere. Custom bent track and rolled studs were essential. Nearly every stud, screw, and angle was customized to match the architectural drawings in 3D sculpt, with most components designed in-house and then fabricated expressly to meet the project's unique design requirements. My favorite judge's comments in all of these came from one who said this project could only have been done with cold form steel framing. And it shows the incredible versatility and craftsmanship involved in building with cold form steel. So I love this shot of the entire exterior of the building. Dark Universe at Universal Epic Universe in Orlando, Florida. Now, new this year, our last award category is Innovative Product. And Innovative Product, we had a couple of entries, and our winner this year is Step Studs, Horizontal Base Studs, LLC, submitted by Michael Cox. So this innovative product in metal design and cold form is unlike anything in the steel framing industry has seen before. Not only has Step Studs received U.S. patents, but it has created a brand new category of framing that has not existed, setting a new industry standard by solving challenges that traditional metal studs can't. The fact that it is patented and has pioneered an entirely new class of metal studs speaks volumes about its originality and impact. It was created by a lifelong journeyman carpenter who, while lying on the floor making another repetitive flood repair, began wondering why the same process was being performed over and over again without solving the problem. The purpose of Step Studs is to lift the drywall up off the floor and keep it dry during most water intrusions or floods. The Step Studs are quick, simple to install at floor level, around the perimeter of a room or an area. They require only one screw at each vertical stud, and they have virtually no waste. They incorporate an air vent system as well as a drain hole system to allow drainage and drying when floods do happen. The drywall sits on top of the non-load bearing Step Studs, lifting it up and keeping it dry. Step Studs is an innovation in construction designed to drastically reduce flood repair costs and speed up room area recovery. By raising drywall off the floor, it prevents mold and mildew growth, eliminating the need for costly drywall removal. The system allows for a 75% reduction in repair costs and a 50% faster room turnaround compared to traditional drywall setups. So congratulations to all of our winners in SFIA awards. Note that the Steel Framing Industry Association BuildSteel website includes the information. This is all at buildsteel.org. And so the 2025 winners are now posted on the website. We want to remind everyone that they can subscribe to BuildSteel by going to buildsteel.org and clicking on this yellow subscribe button that is highlighted on your screen with a red circle in the upper right. And we also want to remind everyone about the AWCI's Build 26 show, which will be in New Orleans on March 15th, 16th, and 17th. Registration is at awcibuild.org. Registration is open now, and it's only 124 days away. This is also where SFIA will be holding their face-to-face meeting, their annual meeting, and at this meeting, we will be completing the vote on the changes to our code compliance certification program. So don't miss being in New Orleans in March 2026 during St. Patrick's Day. We hope you've enjoyed today's presentation. The award submittal period for 2026 will start at the SFIA annual meeting and in conjunction with Build 26 in mid-March with submittal deadline in late June. Also, if you plan on attending AWCI's convention and trade show, the early bird deadline is December 1st, just a few days away. There is no charge for SFIA members to attend the SFIA annual meeting. We hope everyone has enjoyed this, the awards presentation. We thank all of our judges, we thank all of our entries, and we thank you for attending. So thanks. And if you have any additional questions about steel framing or the awards, I am Don Allen, the Executive Director of SFIA. Information about contacts for me and our staff are at steelframing.org, and also information about a lot of these projects is at buildsteel.org. Thanks again. Have a great and wonderful day and week.